I'm explaining exercise 3.6. Okay, in this we will be solving logarithmic equations, right? Now in logarithmic equations, if on both the sides there is same log and it is written with single log, then we can simply cancel out the log. Like if we have log 3x plus 1, log 3x plus 1, and it is equal to log 3 4. On both the sides we have log, right? So we can cancel out this log. We have single log in on both sides. And then we can write x plus 1 is equal to 4. So x is equal to 4 minus 1, that is x is equal to 3. So this is the way we can solve the equation if it is a simple equation, right? Now, one thing, once you have taken out the value, then you have to check by substituting in this whether it is satisfying or not. Because when you will substitute here 3, it will become 3 plus 1, 4. So the log is defined. Sometimes by substituting this value, you get the log which is not defined. So you have to be very much careful. You have to check all the values by substituting in all the logs. Okay. Now, if you have a question in which we have more than two logs in an equation, then what you have to do? Now, if you have log 2, log to the base 2, x minus 1, and then plus log to the 2, x minus 4, and is equal to log 2, 2x minus 6. Now you have here all the logs must be of same base, right? So we have all the logs of same base. Now here we have plus sign. Whenever there is plus sign, you have to write it as single log, then only you can cancel out log. So we have log to x plus, as there is plus sign, so it will be changed to multiplication. These two will be multiplied according to product law. We have log 2 2x minus 6. Now we can cancel out this log 2 and this log 2. So we have here x minus 1, x minus 4, and 2x minus 6. Then we'll do the simplification. It will become x square minus 4x minus x plus 4 is equal to 2x minus 6. Then we have x square minus 4x minus x minus 2x plus 4 and plus 6. So it will become x square minus 7x plus 10 is equal to 0. Now we have here quadratic equation, we'll solve it. So when we will solve, we'll get here x square minus 2x minus 5x plus 10 is equal to 0, and so the values of x are x minus 2 minus 5, x minus 2 is equal to 0. So we have x minus 5 and we have x minus 2. Then we have x minus 5 is equal to 0 and we have x minus 2 is equal to 0. So we have two values of x is equal to 5 and x is equal to 2. Now we have some questions in which we have number as well. What we'll do in this case, there is a number which is without log. We have log 3 x minus 1 plus log 3 x plus 3 and then minus log 3 x plus 1 is equal to 1, right? Now, in this case, we have 1 here. Now, there are two ways to solve it, right? I'll be explaining. One of the way is that you apply log with it. Whenever you know that if we write log 3 of 3, its answer is 1. If we write log 2 of 2, its answer is 1. We can write this as log 3. These two are to be multiplied, x minus 1, x plus 3 upon x plus 1. As this is minus sign, so this will go in division. So we can write this is equal to log, in place of 1 we can write log 3 of 3, because log 3 of 3 will give the answer as 1. So then you can cancel out this log 3 of 3 and then you can solve it further, right? One of the way is this. Another way is that if you write it in single log 3 x minus 1 x plus 3 upon x plus 1 is equal to 1. Now you see this is in log form. You can convert it into index form by making this one, by writing this one as a power of 3. And then you will remove this, the log will be removed because you have changed log form into index form. In both the ways you will be getting the same. You see here, when you will cancel out this, you have got the same equation which you have got here. So either you do it in this way or in this way, it will give you the same result. If it is question number 7. If it is log 2 x minus 1 square, and then we have is equal to 2 plus log 2 x plus 2. One of the way is that you apply log with this. And which log you will apply here? With 2, you can write the log 2 of 2. Right here was 1, so we replaced log it by log 3 of 3. But if it is 2 here, then you have to write log 2 of 2 with it, because 2, it is 2, it is not 1. And then plus log 2 x plus 2. Now what you can do here, you can make this 2 as a power of this 2. So this will become log 2 x minus 1 whole square is equal to log 2 2 square. So 2 square will become 4. Then we have log 2 x plus 2, right? So then we have log 2 x minus 1 square is equal to log 2. We have plus sign, so we'll change it into multiplication, and then we can cancel out this log 2 and this log 2. Either do it in this way or do it in this way, that bring this here on this side. So when you will bring this on this side, it will become log 2 x minus 1 whole square minus log 2 minus log x plus 2, and 2 is there. And here you can write it as log 2 x minus 1 whole square upon x plus 2, and here 2. Now change it into index form. When you will change it into index form, then what will happen? This will remain as it is here, and this will be changed to 2 square. So when you will solve it further, you will be getting the same. It will become x square minus 2a 4 into x plus 2, and then you will be solving it further. You will get the values of x. Now if we solve it, x square minus 2x plus 1 is equal to 4x plus 2. So we'll have x square minus 2x minus 4x plus 1 minus 2 is equal to 0. So we'll be having x square minus 6x minus 7 is equal to 0. X square minus 7x plus x minus 7 is equal to 0. X minus 7 plus 1 x minus 7. So we have x plus 1 and x minus 7. We have two values of x is equal to minus 1 and x is equal to 7. Now we will check whether it is satisfying all these logs or not. If we write here log 2 x minus 1 whole square, if we substitute the value of x here as minus 1, so it will become minus 1 and minus 1 will become minus 2, and minus 2 square is 4, so it will become log 2 4. And if we substitute here 7, then 7 minus 1 is 6, and 6 square is, if you substitute here 7, it will become 6, and here we have substituted minus 1, so I'm substituting here minus 1, and here minus 7 minus 1, so it is log 2 36. And if we substitute in this log 2 minus 1 plus 2, it will be log 2 1, and if it is not square here, so then we have log 2. When we'll substitute here 7 plus 2 is log 2 9. So all these logs are defined. If any of the case is undefined, then we'll not consider that value. And how, when it will not be when it will be undefined, when we'll get minus here, negative sign here, or we get negative sign here. So in that case you will write that undefined, and then you will be writing that value as rejected, right? Okay, so from question number 1 till exercise 3.6, from 1 till 11, all the questions to be done in the same way. After that, there are simultaneous equations. Whenever there are simultaneous equations, you have to change, you have to see how you can change the equations, and then you have to solve simultaneous. Like in question number 12, we have ln 3x minus y is equal to 2 ln 6 minus ln 9, and another equation is e power x to the power 2 is equal to e, and here it is e power y. Now first of all, you have to make two equations. Whenever there are simultaneous equations, you have to make two equations, in this without ln and in this without that e power, without e. So how you will be doing it here, you have to, in this case, you have to write it as single logarithm, and it will be ln 3x minus y is equal to ln 6 square minus ln 9, and then ln 3x minus y is equal to ln 36 upon 9. So 9 fours are 36. You will be having ln 3x minus y. We will be writing on both the sides with single ln. So now ln and ln will be cancelled out. So we have got the equation 3x minus y is equal to 4. Make y the equation, the subject of the equation, 3x minus 4. So this is the first equation you have got. Second equation you will get from here. You will use the laws of indices here. Here you have used laws of logarithms. Here it will become 2x upon e power y, and here if the power is not written, it means e power 1. Then we'll write e 2x minus y. Then when you this will go in the numerator, it will become minus y. So we have powers same, so we can equate the, we can bases same, so we can equate the powers. So we can write 2x minus y is equal to 1. So in this case you will be getting the equation as y is equal to 2x minus 1. This is equation 2. In both the equations you have got the values of x, so you can equate both the values. 3x minus 4 is equal to 2x minus 1. So 3x minus 2x is equal to minus 1 plus 4. So x is equal to 3. When x is equal to 3, then you can find out the value of y as well. So y is equal to 2 into 3 minus 1. Substitute in any one of the equation. So y is equal to 6 minus 1. So y is equal to 5. So 3 comma 5 is the answer. So question number 13 can also be done in the same way. Now question number 14 and 14, 15, these are the two important questions because these kind of questions usually come in the paper, right? So we have question number 14, in which you have log 3. In a part it is log 3 x plus 2 is equal to 3 log x of 3, right? And they have said in the question that you can replace y can be equal to log 3 of x, right? So first of all, the bases are not same. You cannot write as a single logarithm. So you have to make the bases same, right? To make the bases same, you have to either change this or you have to change this, right? It's better if you change this one because we have here 3 of x. It means that this needs to be changed. And how you will change it? You will apply here change of base law. And according to change of base law, if you will take this to the denominator, then it will become, do not write this 3 as a power of this. Just take this to the denominator. So what will happen? This will go here and this will be like this. And then you have to do cross multiplication. When you'll do cross multiplication, log 3, it will become log 3x whole square plus 2 log 3 of x, and then is equal to 3. So it is log 3x whole square plus 2 log 3x is equal to 3. So you can take it as y. You can take, because we have given log 3 of x as y, so this will become y square plus 2y minus 3, it has to be minus 3 here, is equal to 0. Now you have got quadratic equation, solve it, x y squared um, plus 3y minus 3 is equal to 0, then y and y plus 3, and then minus 1 y plus 3 is equal to 0. So we have y minus 1, y plus 3, and then we have y is equal to 1 and y is equal to minus 3. Okay, now if you see, if we substitute here 1, it's fine, but if we substitute minus 3 here, then this cannot be negative and the base also cannot be negative. Okay, after this you will be writing log 3 x, because y was log 3 x was replaced by, so is equal to 1, and here log 3 x is equal to minus 3. So x is equal to 3 power 1 and x is equal to minus 3 with power, sorry, 3 power minus 3. So it will become 3 power minus 3. So x is equal to 3 and x is equal to 1 upon 3 power 3. So x is equal to 1 upon 27. B part is also to be done in the same way. Then in question number 15, question number part A, part E, part B, these are supposed to be done in the same way. You have to substitute, right? And in that question, it is not written that you have to substitute, but you have done these kind of question in question number 14. So you'll be doing it in the same way. I'll be discussing question number 15, part C and D, because those are different. Now in C part, question number 15, C part, we have log 2x and here log 4 x plus 6, right? Now the bases are different, so we have to make the bases same. There are two ways, either to use change of base law, or you can do it in this way, that we have here 2 and we have here 4. So we can, if we take square of this, then it will become 4. So when we will take square of this, if we'll make this as 4, then we have to take square on this as well. And this will become log 4 x plus 6, and then you can cancel out both the logs and then you can solve the equation, right? Is equal to x plus 6 and then x square minus x minus 6 is equal to 0. Now why we can, how can we do this? Like if we have log 2 of here log 2, and here we have 8 and here we have 3, right? If we write it in index form, it will become log 3 2 cube is equal to 8. If I put square on this, then I need to put square on this as well. Then the answer would be same. So if you are putting square here, then you have to put square here as well. So the same I have done here, that if I've taken square of 2, then I have to put square over here as well. Another way is that you can do it by change of base law. How? When you how do you use change of base law? We have here log 2 of x. In the numerator, we can write log 4 of x upon log 4 of 2 is equal to log 4 x plus 6, right? And the answer of log 4 of 2, the answer of this would be 1 upon 2, log 4 of 2. You can check from the calculator. Log 4 of 2 will give you 1 upon 2. Because when you take square root of 2, then you get 2. So its answer would be 1 upon 2, log 4x upon 1 upon 2. And then that 1 upon 2 is to be multiplied over there. So this will become log 4x is equal to 1 upon 2 log 4. This 1 upon 2 will become power. So this will become log 4x plus 6 with power 1 upon 2. Then log 4 and log 4 would be cancelled out. So you'll be left with x is equal to x plus 6 under root. So if you have to remove this under root sign, then you will be taking square on this side. So you'll be getting the same equation, x squared minus x minus 6 is equal to 0. And then we will be solving it by middle term breaking, minus plus 2x minus 6 is equal to 0. X minus 3 plus 2 x minus 3. And then we have x plus 2, x minus 3 is equal to 0. So x is equal to minus 2 and x is equal to 3. Now, when you will take x is equal to minus 2, that value is to be rejected because we cannot have here negative value, right? But this is to be accepted because the log 2 of 3 is possible. So this value is to be rejected.